We start by positioning the FaroFocus 3D laser scanner in the space to be captured. In this case, it is the Maggiano's Italian restaurant. The laser scanner works by shooting a laser that is reflected off of a mirror and measures a distance to a point with an accuracy of 2 millimeters. As the mirror spins vertically, the laser captures a column of points in 3D space. As the base rotates horizontally, the scanner captures a full 360-degree dome of all of the data around it. Now we are in FaroScene, the software used to process the laser scan data. I'm going to start by looking at a panoramic view of one of the scans. This is taken from the point of view of the scanner. As you can see, I can look around the space in all directions and see everything that was captured. We can also switch to a planar view, which takes the 3D data and unrolls it to see all of the space at once. Even though this looks like a photograph, every pixel in this image is a point in 3D space that I can use to take measurements. When measuring from the floor to the ceiling, I can break down the measurement into its components to get a true vertical distance. Now we are no longer looking from the point of view of the scanner, but instead we are looking at a 3D view of all of the data points that were captured from a single scan location. You can see the amount of information that was captured from just one setup of the laser scanner in this room. At this point, I have combined a number of scans taken at multiple locations to create a complete capture of the second level of the restaurant. Here, each scan is given a unique color to help validate the registration. Looking at the 3D view, I'm going to isolate just the scans at the second level to see how the data came together. We can see that the quality of the registration is quite good, and the complete data capture has a high level of detail. Here I'm going to create a clipping box to take slices through portions of the model. This allows me to see the space in ways that would otherwise not be possible with traditional means of capturing as-built information. For example, I can remove the ceiling from the building and see a complete floor plan of the rooms in context of the entire space. By bringing back the scans that I took of the first level, I can see the entire model of the interior of the building. Now I'm going to move the clipping box to take a cross-section of the building through the stairwell to understand how the two levels relate and what is the floor-to-floor distance between them. I have turned on the view of the scans taken at the exterior of the building to look at the complete data capture for this project. From here we can export a number of standard formats for using the point cloud data in downstream design applications. For any of the Autodesk products, the workflow will be to use ReCap to import the native FaroScan files. ReCap is a high-performance, real-time visualization engine that designers can use to review, measure, and annotate the point cloud data. ReCap is installed with all of the standard Autodesk design suites. It also gives designers access to real views, or panoramic photographic views of the data looking from the point of view of the scanner. From within the real view, I can navigate from scan to scan by clicking on the bubbles in the view. Here I can take measurements and add annotations to communicate design intent with the rest of the design team. The designers can search for annotations and markups, as well as save named views for finding them. The ReCap engine is also built into all of the Autodesk products. Here inside of AutoCAD, I can insert the point cloud as a reference and take advantage of using the reality captured data for as-built documentation and planning. Looking at the point cloud from the front view, I'm going to create a section to view the building floor plan. Here I can trace the data with lines to create an as-built floor plan of the building, or take measurements of the space for planning and estimation purposes. Inside of Autodesk Revit, I have the same capabilities and real-time performance when working with the point cloud data. I'm going to start by creating a section view to align the point cloud data with the level datums that I have established for the first floor and second floor of the building. This will allow me to create accurate floor plan views for modeling the building to create a complete BIM. Looking at the floor plan view, we see the plan section is cut all the way down to the floor so we can see the floor's materials and finishes. I'm going to adjust the view range to clip the view just above the floor level. Now our view looks more like a floor plan. I'm going to do the same thing for the second level. The elevation views created from the point cloud are true orthographic representations of the building. This is difficult to capture with traditional photography. I'm going to cut another section of the building, this time taken north to south through the stairwell. You can see that it is easy to create as many views of the data as necessary to get a sense of the space and its construction. And here are the reflected ceiling plans. Capturing this type of information using traditional measuring and surveying techniques is not only difficult, but time-consuming and error-prone. Here, every light fixture, HVAC vent, and sprinkler head are captured at a high level of detail. All of this information can be used to create a highly accurate and detailed building information model for renovation or adaptive reuse projects. Let's look again at the 3D view. We can plan a renovation or addition to this building without even having to model the existing structure. We can work in context of the point cloud. I'm going to start by creating a perspective view to help us visualize our design intent. With the Recap engine built into Revit, we have the same level of high-performance real-time visualization capabilities that we can use to explore and communicate our designs. I'm going to put a new wall into this room to see how it will affect the characteristics of this space. By working in context of the point cloud, I can quickly visualize design changes. Back in the perspective view, we can see how the proposed wall will appear in the existing space. Now let's change the door and see how that will look with the new addition.